If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new topic, that is antiderivatives or indefinite integral. So in this lecture we will see what is the meaning of antiderivative, why it is known as indefinite integral, and some standard formula. Okay, then let's see this. Okay, the topic is antiderivatives or basic level we are discussing, or it is also known as indefinite integral. So how it is known as indefinite integral we will understand after some time. Now suppose fx is a function of x such that the derivative of capital F is small f. So differentiation of this f is small f. Then this capital F is called the antiderivative of the fx. That means the derivative of capital F is small f and antiderivative of the small f is capital F. So derivative of this is this, and if you come back to from this to this, then it becomes antiderivatives. So that is known as antiderivative, that is reverse of derivative, that is antiderivative. Suppose if you take d dx of x to the power 4 is equal to 4x cube. So 4x cube is the derivative of the x to the power 4 and x to the power 4 is the antiderivative of 4x cube. So if you go this way, then this becomes antiderivative of this one. Then x to the power 4 is the antiderivative of 4x cube. Similarly, you can think of other things also. Suppose if I said x to the power 4 plus 5, that differentiation also 4x cube. So the antiderivative of 4x cube is also x to the power 4 plus 5. You can try with the x to the power 4 plus 6 also, that will also be 4x cube because constant differentiation is 0. So 4x cube is the antiderivatives of 4x cube is x to the power 4 also, x to the power 4 plus 5 also, anything. So in general we can write anything x to the power 4 plus c, any constant, is always 4x cube. So antiderivative of 4x cube is x to the power 4 plus c. That's why this c is known as the arbitrary constant. It can take any value. So there is no definite antiderivative of 4x cube. There are so many antiderivatives. This is also antiderivative, this is also antiderivative, this is also antiderivative. The difference is the constant term only. So symbolically what we write, this snake type symbol is known as the symbol of antiderivative, which is known as the symbol of integral also. Integral fx dx. Dx means this symbol. You think it this way. Suppose in differentiation what we do, d dx. This is the symbol. And we do of y. This is the function of what function you are taking differentiation. Integration this and this is the symbol. Here we place the function whose integration we will take. So this snake and this dx. Dx represent on which respect you are integrating. So this snake and this dx together makes this symbol. So there is no product fx into dx, it is not like that. It is just symbol, and in between them we will put fx. So antiderivative of fx or integral of fx is capital Fx plus c, where c is arbitrary constant, because we have seen with the constant there is no change in the derivatives of the original function. X to the power 4 is also x cube, x to the power 4 plus 5 is also x cube. So the antiderivatives also can take any value c. So c can take any value, not a definite value. So the antiderivatives of 4x cube is not definite. There are indefinite numbers of function which satisfies this condition. Differentiation of this becomes 4x cube. So that's why this is known as indefinite integral, because it is not definite any particular, it is not giving any value. So that's why it is indefinite integral of fx. The snake and d are inverse to each other. D means I am talking about differentiation. So this snake and differentiation are inverse of each other. This is antiderivative, this is differential. Now this integration fx dx is also represented by 1 by d. So capital D, generally capital D also represent d dx. So 1 by d represents integration dx, because this is the inverse operation. So sometimes it is also written 1 by d also. Now some of the similarities between your differentiation and integration if we do. So this one you have seen, if it is plus minus differentiation, then in differentiation you can separate it out, and integration also you can separate out. If it is a constant into function, in differentiation constant you can take out, then differentiation of function. In integration also you can do it. So constant you can take it out, integration of the function, and if there is a plus minus of two functions, so you can segregate that integration. So that is similar to your differentiation. This portion is okay, similar to our differentiation. Integration of k is, that is, if you take k out, integration of 1 is x, because differentiation of x is 1, so integration of 1 will be x. So that's why k is taken out, integration of 1 is x. So it is kx plus c. Now u into v dx. So in differentiation we have a product rule, but in integration no such product rule is there. For that we have integration by parts. So that we will learn in the next topic, coming topic. And how do you do integration by parts? Similarly, u by v, no quotient rule here like differentiation. So we have for into and product, we have, suppose there are product of function or divide of function, we apply integration by parts. How to do it, we will explain it later. Similarly, if it is a composite function inside one function, so like your coconut, in differentiation we applied chain rule, we did the outer layer, then we go one by one layer inside. But in integration it is not possible, it is done using method of substitution. That also we will discuss how to apply method of substitution in integration. Now some standard integration formula, x to the power n dx is x to the power n plus 1 divided by n plus 1 plus c. So how do these formulas came? If you do differentiation of this one, it will come. So that's why integration of this one is this. You can check, do this differentiation, you will see this will come. So you remember this way, x to the power n is x to the power n plus 1 by n plus 1, plus c is always there for indefinite integral. Integration of 1 is x because differentiation of x is 1. Differentiation of x log x is 1 by x, so integration of 1 by x is log x. So this one you have to be careful, n cannot be minus 1. If it is a minus 1 then 1 by x, because if it is minus 1 then minus 1 plus 1 is 0, it becomes indefinite. So it is not infinite, it will go infinite. So that's why 1 by x is specifically done with log x, because differentiation of log x is 1 by x. E to the power x differentiation is e to the power x, so integration is also e to the power x. Sin x integration is minus cos x, because cos x is minus sin x differentiation. So that's why inverse. Cos x integration is sin x, because sin x differentiation is cos x. So tan x is sec square, so integration of sec square tan x, cos x cot minus cos x, sec x tan x sec x, cos x square is minus cot 1 by c, because sin inverse is this one, so the integration of this one is sin inverse. Tan inverse differentiation of this one, so integration is this one. So once you know differentiation formula, integration is just reverse. Differentiation of sec inverse is this one, so integration of this is sec inverse. Similarly, a to the power x differentiation is a to the power x into log a, differentiation it is a to the power x by log a. This one can also be proved using method of substitution, but I have given it here. You can directly remember, these are standard formulas, we are not going to derive this one in exam. If you like the video, then press the like button and please give your valuable comments in the comment section.